Dear students, let us study properties of inverse trigonometric functions. Property 1, that is sine inverse of x equal to x, where x belongs to -1 to 1. Here -1 to 1 is range of sine x. Cos inverse of x equal to x, where x belongs to -1 to 1, where -1 to 1 is range of cos x. Tan inverse of x equal to x, where x belongs to R, where R is range of tan x. Similarly, you can prove cot inverse of x equal to x, sec inverse of x equal to x, and cosec inverse of x equal to x. I will prove one result for you. Similarly, you can prove all other result. Let us consider first result, that is sine inverse of x equal to x, where x belongs to closed interval -1 to 1. This one we can prove like this. Let sine inverse of x equal to y. Then what is x? X equal to sine y. Here you can take y belongs to closed interval minus pi by 2 to pi by 2, which is principal branch of sine inverse of x. So sine inverse of x equal to y, then x equal to sine y. Here we are using this result. If f of x equal to y, what is x? X equal to f inverse of y. Okay, that means if sine inverse of x equal to y, x will be equal to sine y. Just like f, sine or sine inverse is a function. That means this property we can use. Therefore, sine inverse of x, this is equal to sine of, in place of sine inverse of x we can substitute y, so you will get sine y. Now what is sine y? Sine y equal to x, therefore we will get sine inverse of x equal to x. Similarly, we can prove cos inverse of x equal to x, tan inverse of x equal to x. Okay, that is our property 1. Now consider property 2, sine inverse of sine x equal to x, where x belongs to minus pi by 2 to pi by 2, which is principal branch of sine inverse. Cos inverse of cos x equal to x, where x belongs to 0 to pi. Here 0 to pi is principal branch of cos inverse. Same way we can prove tan inverse of tan x equal to x, cot inverse of cot x equal to x. Okay, cosec inverse of cosec x equal to x. Let us prove first result, that is sine inverse of sin x equal to x, where x belongs to closed interval minus pi by 2 to pi by 2. Okay, this one we can prove like this. Let sin x equal to y. If sin x equal to y, then what is value of x? X will be equal to sine inverse of y. Here also we are applying the property result, f of x equal to y, then x will be f inverse of y. Therefore, sine inverse of sin x, this is equal to sine inverse of, what is sin x? Sin x equal to y. Sine inverse of y, sine inverse of y equal to x. So we got the answer, sine inverse of sin x equal to x. Same way we can prove cos inverse of cos x equal to x, or tan inverse of tan x equal to x. Okay, now property 3, sin inverse of 1 by x equal to cosec inverse of x, where x belongs to minus infinity to minus 1, union 1 to infinity. And this one is domain of cosec inverse of x, or range of cosec x. Cos inverse of 1 by x equal to sec inverse of x, and tan inverse of 1 by x equal to cot inverse of x. Let us prove result 1. Okay, we want to prove sin inverse of 1 by x equal to cosec inverse of x. Let us consider left hand side, that is sin inverse of 1 by x. Suppose this is equal to y, then what about 1 by x? 1 by x will be sin y. Clear? So take reciprocal on both sides. So we'll get x equal to 1 by sin y, that is cosec y. If x equal to cosec y, what is cosec inverse of x equal to y. Now we can equate equation 1 and 2. So what we'll get? Sine inverse of 1 by x is equal to cosec inverse of x. Same way we can prove cos inverse 1 by x equal to sec inverse of x and tan inverse 1 by x equal to cot inverse of x. Now property 4. Sin inverse of minus x equal to minus sin inverse of x, where x belongs to minus 1 to 1. Tan inverse of minus is equal to minus tan inverse of x. Cosec inverse minus is equal to minus cosec inverse of x. Actually, sin inverse, tan inverse and cosec inverse satisfies similar property because their principal branches are almost same. What about principal branch of sin inverse? Closed interval minus pi by 2 pi by 2. Principal branch of tan inverse is open interval minus pi by 2 pi by 2, and principal branch of cosec inverse x is closed interval minus pi by 2 pi by 2 minus 0. So let us prove result 1. Result 1 is sin inverse minus x equal to minus sin inverse of x. So let us consider left hand side. Let sin inverse minus x equal to y. Then what is minus x? Minus x will be sin y. Therefore, what is x? Minus sin y. Since sin is odd function, we can write minus sin y as sin minus y. So if x equal to sin minus y, what is sin inverse of x equal to minus y? Now we can multiply both sides with negative. So we'll get minus sin inverse of x equal to y. Now we can equate 1 and 2. By equating 1 and 2, we'll get sin inverse of minus x equal to minus sin inverse of x. Same way you can prove tan inverse of minus is equal to minus tan inverse of x, and cosec inverse minus is equal to minus cosec inverse of x. Now next result. Cos inverse of minus is equal to pi minus cos inverse of x. Sec inverse of minus is equal to pi minus sec inverse of x, and cot inverse minus is equal to pi minus cot inverse of x. Actually, principal branch of cos inverse, cot inverse and sec inverse are similar. What is principal branch of cos inverse? It is 0 to pi. Principal branch of cot inverse is open 0 to pi, and principal branch of sec inverse x is closed 0 to pi minus 0. Let us prove first result. We can prove cos inverse minus x equal to pi minus cos inverse of x. Let us consider this left hand side. Cos inverse minus x equal to y. Then what is minus x? Minus x will be cos y. So x will be minus cos y. So instead of minus cos y, we can write right hand side as cos pi minus y, right? Because cos pi minus x is minus cos x. Cos is negative in second quadrant. That result you have to apply, which implies cos inverse of x will be equal to pi minus y. So what is y? Y equal to pi minus cos inverse of x. Now we can equate 1 and 2. By equating 1 and 2, we will get cos inverse of minus x equal to pi minus cos inverse of x. By using same method, you can prove sec inverse minus is equal to pi minus sec inverse of x, and cot inverse minus is equal to pi minus cot inverse of x. Now by using these basic properties, we can find principal value of different inverse trigonometric functions. Let us consider one question. Find principal value of sine inverse of 1 by root 2. Principal value means value of inverse trigonometric function in the principal branch. That means here you have to find the value of sine inverse of 1 by root 2 in minus pi by 2 to pi by 2. Value should be in between minus pi by 2 to pi by 2. Let us consider question. That is sine inverse 1 by root 2. Actually, here you have to apply the properties that we already studied. Method is one. You have to change 1 by root 2. You have to express 1 by root 2 in terms of sine. Then you can use the property sine inverse of sin x equal to x if x belongs to closed interval minus pi by 2 pi by 2. How we can express 1 by root 2? 1 by root 2 means it is sine pi by 4. This value equal to pi by 4 because pi by 4 clearly belongs to the interval minus pi by 2 to pi by 2. Okay. Now consider second question. Find principal solution of cos inverse. Cos inverse minus 1 by 2. Here you have to use the result cos inverse minus x first. What is cos inverse minus x? That is pi minus cos inverse of x. Therefore, cos inverse minus 1 by 2. This is equal to pi minus cos inverse 1 by 2. Okay. Now this is equal to pi minus cos inverse 1 by 2 you have to express in terms of cos. Cos 60 is 1 by 2. 60 is pi by 3. Now here you can apply the result cos inverse of cos x. Cos inverse of cos is equal to x if x belongs to 0 to pi. So cos inverse of cos pi by 3 will be equal to pi by 3 because pi by 3 clearly lies in between 0 to pi. So this answer is pi minus pi by 3, that is equal to 2 pi by 3. Okay. Consider third question. Find principal solution of sec inverse of 2 by root 3. Here first you have to apply the result sec inverse of 1 by x. What is sec inverse 1 by x? That is cos inverse of x. Therefore, sec inverse of 2 by root 3. This is equal to cos inverse root 3 by 2. Okay. Now, this is equal to cos inverse root 3 by 2. You have to express in terms of cos. Cos 30 is root 3 by 2. So, cos pi by 6. Now, cos inverse of cos pi by 6 equal to pi by 6 because pi by 6 clearly belongs to the interval 0 to pi. So, principal value of sec inverse 2 by root 3 is pi by 6. Dear students, finding principal solution is one important question. So, today we studied some basic properties, and using the basic properties, we studied how to find principal solutions of inverse trigonometric functions. Today we can conclude this section. Tomorrow we'll study new properties. Okay, thank you.